All right. Hey, team. Welcome to Colbyashi Maru, the show where devs all over the world boldly face off with the most logical tools on the web. I'm Colby Fayok, your Space Jelly commander and host of today's challenge. Today, we have Sid Palas. Sid is a software engineer with DevOps Directive and also creates some awesome DevOps related content over on YouTube. Let's bring him in. Hey, Sid, do you want to give yourself a quick intro or do you have anything else that you'd like to add?
Hey, Colby, thanks so much for having me. I think that intro was great. Yeah, I split time between freelance consulting, mostly for startups, helping them build out their software infrastructure and apply DevOps practices to their systems, as well as making content for both my YouTube channel and my blog.
Awesome. Well, for those of you that are new to Kobayashi Maru, sorry, my notes. Our guests will have 1 hour to work through their project challenge. Through that time, Sid will try to talk out loud as he's working through that challenge. I'll be asking some questions along the way, so if you have questions, make sure to send them over and I can field them over to Sid. Today, Sid will be facing off against building out an over-engineered static site deployment pipeline with Kubernetes and DigitalOcean. If he doesn't finish that challenge, all's not lost. We'll see if we have enough time to finish up, or we'll chat about what the next steps could look like. Sid, before we actually dive in, do you want to talk a little bit about the tools you'll be using? And I'll bring up your screen, so if you want to show anything off.
Sure. So the actual site or app that I'm going to be using as the basis for this challenge is quite simple. I'm just going to kind of use the Create React app, swap out some of the default images with some nice Colbyashi Maru branding. I took your video and stripped out this little GIF so I can replace the React logo with that.
Love it.
And that just serves as sort of this example static site that then we're going to do a few things with. We're going to Dockerize that. So we're going to take it, build the static assets. So the JavaScript, HTML, and CSS that it will produce, put those into a container running nginx to actually serve those files. We'll push that container image to a registry, and then we're going to create a Kubernetes cluster running in DigitalOcean. So Kubernetes is a tool that helps to abstract away the need to think about, I have one server or two servers or 10 servers, and it brings them all into one cluster that you can make a request and say, deploy 5 copies of my app with this many CPUs and this type of networking. And then it handles a lot of the details of doing that under the hood. So we'll create a cluster, we'll set up all the configurations to do that. We'll deploy our app, we'll make sure that it's working. Ideally, we'll set up DNS so that we'll be able to connect to it, and anyone in the audience can connect from the URL that we set up. And then we'll do a few things to sort of poke around and show the capabilities that a platform like Kubernetes provides. All of this is way overkill for a simple static site like this. You should just use Netlify or GitHub Pages, but I thought this would be a fun way to show off Kubernetes and explore some of the capabilities and the principles. And so happy to answer questions along the way as we do that.
That's awesome. Yeah, I've heard a lot about Kubernetes, but never actually been able to get my hands on it. But I think it's a great example use case because a lot of us are familiar with static sites, right? So it's a good way to try to learn through it. So if you're ready, I think I'm ready and I can switch on the timer. You good to go?
I'm good to go.
Okay, so 3, 2, 1, let's do it.
Yeah, so ahead of time, I created this little to-do list that I can refer back to if I get lost and I'm not sure what to do next. I did do 2 things off screen. So I created a project within DigitalOcean, which I can pull up my account here. Created a new Colbyashi Maru project within DigitalOcean. There's nothing in here. If we look, there's no apps, there's no VMs, there's no nothing. And then I also went ahead and installed DigitalOcean has a command line tool, doctl. I think I just used Homebrew to install that and connected this to my DigitalOcean account. So those are sort of the prerequisites that I handled off screen before doing anything. And like I said, I produced this nice little GIF to make our styling a little nicer.
We roll with GIF here.
Okay, GIF, cool. So the very first thing that I was going to do is to actually create the cluster in the DigitalOcean interface. We can do this from the GUI. We can just click a few buttons. That's what I'm going to do here for the sake of time. We could also do it from the command line via this CLI, or we could use a tool like Terraform or some other infrastructure as code tool to define exactly how we want things configured and then deploy with that tool. If we were doing it the real DevOps way, we would want to do that. But since this is a one-off where we're really crunched for time, I'm going to go ahead and create it from within the interface here. So I'll just go to Kubernetes, create a Kubernetes cluster. I'll put it in San Francisco because that's where I am. We're going to leave it in the default virtual private cloud network. If we wanted to isolate this cluster from other resources in our account, we could create a separate VPC to do so. Let me just zoom out one click. There we go.
And what's a VPC for those of us?
Yeah, so virtual private cloud is an isolated network within a broader cloud context. So I could set up a VPC specifically for this project or specifically for a few of my projects. And this will be scoped to, like, things within it will be able to communicate. Things outside of it, you'll have to set up specific rules to be able to access.
Cool.
Yep. We then can choose the cluster capacity. So the way that Kubernetes is set up is there are some control plane nodes. And so a node here is a virtual machine or a physical machine, in this case, a virtual machine in DigitalOcean, that will run all of the necessary software to handle the clustering and the deployment and all of the underlying functionality that Kubernetes has. That all lives on the control plane nodes. In this case, DigitalOcean manages those. So we don't have control of them. They happen behind the scenes. What we do have control over and what we're choosing here are the worker nodes. And so these are machines where we'll be able to schedule our workloads where our actual application is going to get deployed. And so we're just going to have one node pool, basic nodes. I'm going to choose a inexpensive $10 a month node, and we could pick any number of nodes here. I'll just leave it at 3. So this will provision 3 worker nodes that we can schedule stuff onto. We could set the name of our cluster if we wanted to. I'm just going to leave it as default, and I'll put it in our Colbyashi Maru project. Great. That'll take a few minutes to get set up. In the meantime, I can go ahead and pull down the configuration, so I'll be able to connect to it. So it gives me this command, which I will run. And this just basically pings the DigitalOcean API, gives me a config file with the secret key required for me to authenticate into that cluster. And so now if I do kubectl, I guess that's another prerequisite, is kubectl is the command line tool that that Kubernetes uses, or that you use to interface with Kubernetes. So I can do like get nodes, and because it's not online yet, we'll probably not get anything back. But once that cluster finishes getting set up, we'll run that same command again, and it'll tell us, here are the 3 nodes that are associated with your cluster. Okay, so we can check that one off, and that one. Next up, we're just going to create a super basic React app. So we'll do cd Colbyashi Maru, npx create React app.
We have a question here. Do you plan on using container?
Containerd is a container runtime. Yeah, so containerd is a specific container runtime. In this case, I'm going to build my image with Docker. I am not sure which version of Kubernetes I just deployed. I probably should look at that. But depending which version of Kubernetes is running on the cluster that we just deployed will determine whether or not it has the Docker runtime installed by default, or just containerd, or some other runtime.
Got it.
So, yep. Where were we? So we are creating our site. It's coming up. All right. And now we're done with that. Yarn start. And so for people familiar with React, this process of bootstrapping an app with create React app is pretty straightforward. That is now running a development server locally on my system with the default settings on port 3000. And so what I will want to do then is customize it with the stuff that we wanted. So we can go into our index.js. Our app.js, where we actually have our header defined. And we're going to replace our logo with that GIF. So I'll just move it into my source folder. And then this will be jelly commander.gif. If we save that, oh, we have it rotating. Presumably that is how they make the
I
React
don't mind
logo.
it rotating.
Yeah, I'm gonna stop it from rotating.
Probably
I think
should.
that's just included in our from this app logo class. So we'll just get rid of that. And now we have our nice logo. And we'll replace this with Colbyashi Maru. Couple of emojis. And we don't need that link. Okay, so that is the basic site that we're going to run with to get started. I think most people in your audience are probably pretty familiar with that process, so we're not going to spend too much time on it. All right. Next up is we want to Dockerize this. So right now it's running in a development server that is hosted within Node.js. We're going to use a tool or a server called nginx instead, which is a production grade server that is used on tons of websites and can handle many, many inbound requests. I think that it was designed to handle like 10,000 concurrent requests, and that was 10 years ago or something. So it's a pretty impressive piece of technology.
Similar to my mispronunciation of container D, I used to pronounce it, what was it? Nginx, because I didn't realize that it was nginx. Yeah. That was an embarrassing one in the middle of my work.
Cool. So I will just, I'm going to do two things. I'm going to not add a new folder. I'm going to add a make file. And so make is just a Unix utility that is often used for compiled languages, but I use it just to store a bunch of little commands that I'm going to need later. So I might have a build command, and then for now, I'll just put a placeholder. And so if I am in this file and I do make build, it just echoes back hello. So I can put all my commands there and use template strings and stuff to build those commands up with different variables, etc. That way I just don't have to type over and over the same thing. When you're doing DevOps work, a lot of times you're changing one little piece of the config and then reapplying it, and then changing one little piece. So you don't want to be retyping your commands every single time. I'm also going to, I'll put the Docker file inside of site. And so Docker file is how you define what goes into this container image. You start from some base image. In this case, I'm going to use the official nginx image from Docker Hub. And so many companies and software providers build these official base images that you can use to start. So this will be based on some Linux variant. There's some that are Alpine based. There's some that are Debian based. I'm just going to use version 1.19, which looks like the latest minor version, 1.19. Okay. And then that is how I start. And then I can put in a series of commands that get run that sort of add things into this image. And the image is, if you think about like an object-oriented programming, the image is like the class and the container is like the instance of that class. So we can take one image and spawn many, many containers that are all running based on that same package of dependencies and application that you included in the image.
And that image is also kind of like the state of like an environment, right? It's like, or no?
Yeah, so it includes your application and all its dependencies. It doesn't include like the environment variables and the runtime file system, et cetera. So you take the image and then you add like one additional layer of like the actual runtime environment where you spawn your app and you can store temporary variables or files. And that combined is what makes up the container.
Cool.
But let's just make sure things are working. I'm going to move the makefile in here too, just so we don't have a bunch of commands to change directories and that sort of thing. And then I'm just going to do Docker build period. And so this is telling Docker to find the Docker file in this local directory and build based on it. So if I do make build, from within the correct directory. It went off and pulled that image, the base image, from Docker Hub. So that's the official registry from Docker. There's each major cloud has their own registry. I'll probably use the DigitalOcean registry to store my particular image, but it grabbed it from that public registry and downloaded it, and then stopped. There were no other commands that it needed to do. In this case, though, we're going to want to build our React app files, right? And so I pre-built it. No, I didn't. Let me just do a yarn build. And so this will produce those static files. I'm going to do this inside the Docker container, or inside this Docker file eventually, but for now, I'm just going to build it outside and then copy it in, just to showcase something. And so that produced this build folder, right, with all of our static assets. And effectively, we need to copy those files into our container. So we'll do copy, and that'll be build. Actually, I'll set we want all of build, and we're going to copy that to, there's a specific location that the nginx container is expecting to serve its website from, and that is user share nginx HTML. Okay. And so now I'm also going to do one more thing. I'm going to tag this image and name it nginx Maru nginx.
And that path that you added inside of was it the Docker file?
Yep.
Was that just like the default path that particular image uses?
Yeah, exactly. So this is my local path of where I'm copying from. So that's copying this build directory and all its contents. And then this is the path that nginx is expecting to serve its website from, effectively. You can configure that within a config file, but by default, it's going to look at that path for an index.html and all the associated files.
Cool. And hey, Alex, welcome. Thanks everybody who just rated in. You're currently watching Sid Palas over engineer static site deployment with Kubernetes and DigitalOcean.
Nice. Docker build. Builds up to me. Failed to solve. Copy was. Oh, it's not a colon here. It's a space. Okay, so we started from that initial step. And that's the really nice thing about Docker is that it actually caches each of these commands. So if you change something, you won't have to rerun everything. You'll only have to rerun from the point it changed. And so you want to be careful when you're building your Docker files, what order you do things in. And we'll take that into account a little bit later. But it looks like it completed. And so I'm going to actually execute that container now locally and just make sure that the files that I wanted to be there are there. So I tagged it with that. I could do. Oh, what time are we at?
So that's 45 minutes remaining.
Whew, all right, good. And we're going to port forward. So by default, you won't have access from your local host into the network on the container itself. But if I use this -p flag, I can port forward, let's say from 8080 on my local host to port 80 inside that container. And 80 is where nginx is going to serve by default. And so if I go here and now go to my Zoom controls are in the way. Okay, there, now they're out of the way. Localhost 8080. So now we're serving not from the Node.js development server, we're actually serving from that nginx server. So that is a good step forward. There is one additional change that we're going to want to make though, and that is, remember a second ago, I built the site outside the Docker file and then I copied those files in. That's not a very repeatable process because I'm not going to, my Mac OS system is slightly different than the Linux system inside that container. And so eventually if you start using more complex dependencies, you'll run into issues there. And And so instead, I'm actually going to start from a node base image. Again, I'll go here and find the official node base image. And I will use version 16 Buster, maybe 16-Buster. And I want to copy in my package.json. First, I'll set my workdir, user source app. So this is telling the Docker file sort of what to set as the current directory that I'm using as my working directory. I'm going to copy in my package.json to the same. I'm going to copy in my yarn.lock. Then I'm going to run yarn if it's available. We'll find out if it is. If not, we might need to install it first. Cool. Then I want to copy in my source code. And I'll actually just copy in everything. And I'll add a Docker ignore. And within this Docker ignore, I'm going to add my node modules because anything I've installed locally, I don't actually want to copy those in into the container image. We'll use this again in a minute.
Yeah, this copying process, when I've tried to work with Docker before, the copying process has always thrown me for a loop because, what to copy and where it gets copied.
Yeah. It is hard to think about when you first get started with Docker, sort of like what lives on the host, what lives in the container, what is ephemeral and will be deleted when the Docker container stops, and what is persistent. And so building up a mental model around that is, what's going on here? Make build image. I had a naming conflict there where I had a build folder and I had a make target named build. So it kept saying like, nothing has changed about build. I don't need to build it. And so that's why I just changed the name of that. Copy, what did I do again? Oh. So it's doing its thing. It's installing all the dependencies for my node app into that image.
I think one of the funnier parts about any of the DevOps work I've ever done, like I've done like CloudFormation and Jenkins stuff, is the amount of time you have to spend waiting for a deploy or build to finish. And it's like, it's that weird area where it's like, do I go and do something else? Or by the time I start doing something else, it'll be done.
Yeah, exactly. Well, I can, the cluster should be up by now. So I can do kubectl get nodes. And we see those 3 nodes that I provisioned, and they are 12 minutes old. That's a good timer for myself since I can't see the clock. I'll just check that periodically. Now we're still running yarn. Jeez Louise. But the reason that we did this in this order of like copying in our package.json and yarn.lock before copying in everything else is that every time we change our source code, this line will be modified, right? But we're very rarely or much less frequently going to modify the dependencies of our app. And so if we run this once, then whenever we change source code, we won't have to reinstall all the packages inside the container, and those will be cached, and we can just recopy stuff in, which is very fast. So while this build step is taking a long time, the future build steps should be very quick, unless we go in and add a new dependency or something like that.
It's cool to see that they're packaging the yarn by default.
Yeah, they have both npm and yarn, I think, within that base image. So that is nice. We're getting close. We're on our final step here. Copying in the files. The final thing, though, that we're going to need to do is the yarn build command, right? So this is going to actually create the files that we care about. So I'm going to rerun that, and hopefully it should just cache all the way to that step. And then, yeah, we made it right to 7 to 7.
Oh yeah, that was much quicker.
Yep. And so the next thing that we're going to do is actually take these files. We're going to use what's called a multi-stage Docker file. And so it's a little more advanced of a technique, but we just built our files, and now we can actually reference that first stage up here. So I can say as builder, and now down here, I can have essentially a whole nother separate thing where I say copy from builder. And now within builder, those files are going to live here. Because we set our working directory as that. And then when we ran yarn build, it created that build directory and put those files there. So now if I run again, it should run through this first part, then run the second part, and copy files from the first stage into the second stage.
And what is the benefits of doing that second stage approach as opposed to just continuing one big stage?
Yeah, so the fact that I was able to use these official Docker images, I could like install nginx inside of this container, but there's a whole bunch of configuration and setup to do that. And so instead, I'm using these officially supported images with their best practices already baked in and not having to manage that myself. And so I am able to have all the build dependencies that I need, and like yarn was there by default, as you noted, whereas yarn would not be available by default in this one. So I'd probably have to go install yarn, then do some other stuff. I could have done that, but that's why I decided to go with this
that makes sense,
multi-stage approach. So now I should actually be able to rerun, make run, and test that we are still, refresh the page. Okay, we're still functioning. So that is good as well. So we have successfully Dockerized our application. Next up, we need to push that image into the container registry on DigitalOcean. So I'll go here to the container registry, pushing images. Hopefully their documentation is good. I will do, I think I've done this once before, but it probably doesn't hurt to do it again. Okay, looks like it worked, maybe.
Success.
Yeah, exactly. So apparently, I believe what that does is it uses that Docker command line tool to grab an auth token from DigitalOcean and store it where Docker is expecting to find its credentials. And so now all I need to do is tag and push that image. So I tagged it by default here. I'm gonna now take that tag and add it to, I'm gonna add another tag to the same image. So you can have as many tags as you want on a given image. And this tag is gonna be formatted specifically with this DigitalOcean registry URL. I'm gonna create one here.
And it looks like that registry is your own personal registry, right?
It is specific to, yeah. So this is a private registry. You can make public registries. Docker Hub, the default is to have them public. That should be fine. I'm trying to see if I need to create it first here before pushing to it, or if it'll just magically create it when I push it. Like, what is the name of my registry? Oh, maybe it's just DevOps directive. Yeah. Cool. And then push image Docker push, and then we'll provide it that tag. And for now, I'm just going to tag it with latest. We'll probably add a numbered tag to it. And if we make it to the GitHub Actions portion, then we'll use like the Git hash to actually tag these so they're uniquely identifiable.
Like a version.
Exactly. And I will also add the make file to my Docker ignore. Just so what happened there is I changed the make file, it got copied in, and so it thought it was unable to use the yarn build cache step, even though the make file didn't change anything about that. But luckily, as long as we don't touch this stuff, that's the really slow step. So now if I do a make push, it looks like it is successfully pushing, and we should see it pop up here in a second once that finishes.
While that's waiting, we have Codam in here, and he's asking, is using a makefile is using a makefile with Docker a standard practice? They never really saw that in their limited experience. Only see makefile in C++ repos.
Yeah, you certainly don't need to. I use a makefile in lots of different repos. And as you can see, these are not really build commands in the sense of like compiling a C++ program. They're just little shell commands that I want to store off. You could just put this in a shell script and source that file so that you could call individual functions from that shell script. On Mac and Linux, this is a very convenient way to do it. I know it bothers some of my viewers who are on Windows because it doesn't work out of the box. So I should figure out a better cross-platform solution for that, but I haven't yet.
Fair enough.
Auth Docker. This one, I remember the first time that okay, there it is. So we now have our image here. It is 53 megabytes, which is a little big, but that's okay. Not too bad. I could have used a Alpine-based nginx image. Maybe I'll do that just so we can make it even smaller.
Curious how much of that is like the npm dependencies, like the net dependencies.
So in this case, because I use that multi-stage build, none of the npm dependencies should make it in, right? Like those all were in that first stage, and so now it's just that nginx image. So I think if I actually just do 119 Alpine, we should see it jump down quite a bit. I have a whole video about trying to make the world's smallest Docker container, and I managed to get it down to six kilobytes, I think.
Damn.
World's smallest useful Docker container. So it still contained a web server that was written in assembly, not by me, but it was a fun challenge. Let's just refresh and see how much time we've wasted here. 21 minutes. Okay, we're still doing okay. And I'll get another alarm at the half-hour mark, right?
Yep, and that's in literally like 40 seconds.
All right, we're halfway there. How are we doing halfway on our to-do list yet? Not quite. Okay. Pressure's on. So that is building. We're pushing to our registry. Oh, I was going to go in here to the settings on the registry. And within my Kubernetes cluster, I think I have to like tell it. I have to authorize it to be able to use it. Yeah, here we go. Pull images from this container registry. There it is.
There we go.
More. This is what we want, using images with Kubernetes workloads. Registry page, click edit on Kubernetes integration. Am I too zoomed in? It's not showing me everything. In the settings tab, settings tab. Okay, now we're talking. Edit, integrate all clusters. So this is the cluster that I set up. Either one of these would work. I'll just do this for now. This is basically gonna, behind the scenes, add a secret into my cluster that it will be able to use to authenticate to this registry. Otherwise, I would tell Kubernetes to spawn my app, and it would say, I'm not allowed to get that image, and then it would get stuck. But now that I just did that, it automatically added that for me.
Nice.
All right. So next up, we actually get to start doing some Kubernetes things. So I will add a new folder here at the top level. Just call it Kubernetes. And in Kubernetes, there's a number of different workload types. We're going to use a deployment, which is what you use for a stateless, long-running process. So in this case, a web server is that. We define a few things about it. There's also jobs. So a job you would use if you need to run a workload one time to completion, whereas a deployment stays open forever. There's also cron jobs. You can schedule jobs that are going to recur over and over, and a number of other things. But a deployment is what we want here. These are all defined with YAML. And I will just start by going and getting the default Kubernetes deployment boilerplate. So what is it saying? It's telling us which API within Kubernetes we want to use. It is of kind deployment. The default example is nginx, so that's nice, but we can call it Colbyashi Maru nginx. That's a little long, so we'll get rid of deployment there. The app name just needs to match in a few different places. So it's just a label that's applied kind of metadata that Kubernetes uses to match up certain other things that we're going to provision down the line. And then our container, they're just using this default container, but we actually want to use our container tag here. It is complaining at me because I don't have, it's fine.
Syntax or?
No. Yeah, so I have a linter for Kubernetes stuff that is saying resources. That's saying I'm not requesting specific resources. So if you don't tell Kubernetes how much CPU and memory you want, it'll try to figure it out, but that's a little bit dangerous because it doesn't actually know what it needs, and it might try to schedule too many things onto one node. Yeah, actually, I'll just grab a block. Yeah, so it's gonna look something like this.
That's basically like computer memory and size, right? Yeah.
Yep, so you're saying how much memory and compute you need. In this case, I don't know, let's give it 100 megabytes of memory, which is probably more than it needs, but that's fine. And we'll give it, I don't know, half a CPU. We can give it more if we want, less if we want. And then let's set replica count to 1. We'll change that in a minute just to show what that does. But this should be sufficient to now spawn our application. So I can do kubectl. Let me get into the right directory. Apply -f, and then the name of the file. And so it tells me that it was created. And so the really nice thing about Kubernetes is you're defining everything declaratively. You're saying, here's exactly what I want my app configuration to look like. And then Kubernetes handles all the details of the API calls behind the scenes to look at the state of the world, what currently exists, what needs to change, comes up with a plan, and then goes off and executes that. Versus me saying, spawn one copy of my app. And then like later, I need to know that one copy is running on that VM, and do I need to shut it down to start up a new one, etc. But if I do kubectl get deployments, oh, sorry, get deployments, it tells me that here it is. There's one pod of one replica that I requested running. It is up to date. It is available. It's 40 seconds old. If I wanted to get logs from that pod, I can do kubectl logs, name of the pod, logs. Oh, sorry. I need the pod name. That was the deployment name. So I'll do get deployment. And so deployment is sort of the thing that's managing the underlying pods. And so a pod is the smallest logical unit within Kubernetes. In this case, I said I want one replica. So it's that deployment manages that one replica as a pod. So this is the actual pod, and you see it has all this random stuff because eventually we're going to have multiple. We can spin up 100 of these in parallel, which we'll do in a bit. But if we want to see logs, I was doing kubectl logs. And this is going to grab the logs from that container and print them out. And so we see all that login startup stuff from the nginx container, just like we did when we ran it locally, but now it is in that container on the cluster. We also can now essentially open up a proxy from our system onto that container and test out that it's actually doing what we want, even though we haven't hooked up ingress from the outside world yet. So I can do a kubectl port forward, port dash forward.
While you're doing this, we have a quick question. Another one from CodeDam. Does running containers with Kubernetes give raw Docker engine API-like access? It says one reason they've never tried Kubernetes is because they believe they would probably lose that ability over that abstraction.
So up until I think version 1.19, maybe 1.20, you did have.
All right, we're back, and let me restart the timer. I'll even give you like 5 minutes. Does that sound good?
Sure. We're making good progress though, so let's see how we've got the official clock from these the node ages though, so we'll know. Are we live?
Yep. Sorry, we're live.
Right. We're live. Okay, cool. It was that question about Docker access that Kubernetes didn't like, I think.
Yeah.
So what I was doing though, right before we lost our connection, is I was going to port forward from my local system onto that container running in Kubernetes. And so now, once again, I should be able to go here and on port 8080. So now I'm actually connecting in from my local system over that port forward connection that I just made into that container running on Kubernetes.
And is that on DigitalOcean at this point?
Correct. Yeah. So the cluster, anything that is in Kubernetes that I mentioned is running on that cluster on droplets in DigitalOcean. So Kubernetes is just an abstraction over that, but it is providing my compute and memory from that droplet to my container. Great. The other really nice thing about Kubernetes is that this replicas number, I can just change this to, let's say, 10 and reapply that configuration. And now if I do get pods -w, we see 10 new pods all scheduled. Right now they're pending, but then they'll start to come online as they get scheduled onto these nodes. And depending on my requests, I may have overshot, but we'll see here. And I'll actually look at what these pods are telling me. I can do kubectl describe pod. So it's saying there's not enough CPU on these nodes. So I'm actually going to drop this down to like, I don't know, a quarter of a CPU per. And now more of them start to come out of pending state into container creating state, which is good.
So as soon as you apply it, it's automatically going to go through and update all those nodes.
Yeah, all those pods. Yeah, the nodes. Pods. Yeah, exactly. That is correct. I would have expected more of those to get scheduled though, because I have those 3 nodes.
So can you give a quick, if you have time, a quick explanation of difference between a node and a pod?
A pod is the thing that we are scheduling, the container, the workload. A pod contains one or more containers. In this case, it's just that nginx container. Okay. A node is a virtual machine that is a part of our cluster and is what the pod gets scheduled onto. So Kubernetes says, I said, give me 10 copies of this pod with this much resources. Kubernetes then looked at our cluster and said, you have these 3 nodes. Here's what you have available. Let me schedule them in this way.
Okay. That makes sense.
Yep. So looks like a bunch of our...
And Kodam's asking, does a node equal a physical host?
In this case, they're all virtual machines because they are running in DigitalOcean, and droplets are virtual machines, but it could be a physical machine. It could be a virtual machine, but it is a host. Hopefully that answers the question.
Yeah.
Yeah, so we have about half of our pods running. It looks like we just didn't have enough resources to schedule all those, so I'll just drop it down to 5 for now. And so because I dropped that number, it now terminates some of those ones that it didn't have resources for, and we'll just clean those up. And eventually, we'll get down to having just our...
Yay, we're back.
Whew, all right, cool. So what I was showing there is I was doing this get pods command, and it shows us that it's terminated all those pending pods, and now we have our 5 replicas running in parallel. We also now want to load balance across these, right? So instead of having connections to each one, we want to have inbound requests come, and whichever one, there's a few different load balancing strategies you can use. I forget what the default is. Basically, inbound requests will get distributed across these to handle the load. And so to do that, I'm going to use a load balancer type. And so Kubernetes actually has hooks into most of the major cloud providers. So when I do this load balancer type, it's going to provision a DigitalOcean load balancer, which does cost some money to keep up and running, but it will automatically provision that in my DigitalOcean account. And so the default load balancer command is basically something like this, where it is a type service. So a service can be used as an internal load balancer, where we would set it up and it would load balance across our 5 pods, but without any external connectivity. But because we're gonna use this type of load balancer, it will create an external endpoint that we can hit, and it will route traffic into our cluster, and eventually to hit those pods. There's a few different sizes of load balancer depending on the level of traffic you're expecting. And so LB small should be fine for this. And I'm just going to do HTTP and not worry about HTTPS for now. We could set up a certificate and have the load balancer forward HTTPS traffic as well.
Makes sense.
And the way that this connects to our application is through this selector. So we named our app nginx right here. It will align with that and connect to it because we're using that selector. It'll look for the app named nginx and connect our load balancer to that set of pods.
There we go.
All right. Third time's the charm. Third time is the charm. So while I think my screen was offline, I actually did the kubectl apply for this file as well. And so that is going to go off, and it created this load balancer service. We see that it is pending. Once that comes online, we should have a IP address that we can hit from the outside world and access our app. Lots of stuff going on here in the background. Oh, doesn't like that. Uh-oh. So we now have an external IP. So nice. If I go to that external IP, we see our website. Cool.
Nice.
I'm going to do one thing here let's prove to ourselves that there's actually multiple copies of this thing and it's load balancing across them. We need some information that is unique to each container, right? And so we can do that by adding an environment variable.
Just from a high level overview of what's actually happening. So you're hitting that one IP, and then Kubernetes is splitting off that traffic in like a tree to those different available nodes.
Exactly, yeah. So cool. That load balancer is actually, I believe, running outside of the cluster and is handled by by DigitalOcean. So it's a DigitalOcean specific thing. Google has their own load balancer. Amazon has theirs. You can set up ingress where you have inbound traffic to the cluster and you're running essentially your own ingress controller where you can say, based on either the domain that this request came in on or the route that is appended to it, do X with this traffic. And so you can have a whole configuration of like send traffic for this domain to this pod, traffic for this domain to that pod. If you hit this route, do something different. So you can set up a very complex system to handle as many services as you might have. So companies have literally hundreds or thousands of services running inside of clusters like these. Yeah.
For things more complicated than a static site.
Yeah, exactly. So this hopefully gives people a sense of like what Kubernetes can do. And then when you start to break up your application into a bunch of services, this tooling that we're seeing of like scaling up and down and automatically handling rollouts and scheduling onto nodes and not having to think about, do I have space or not? And it sort of figures all that out for you, is really the power that Kubernetes brings. But we wanted to add within the deployment.yaml, I'm going to add another key under my basically application template. And that is going to have an environment variable. And I'm going to name that environment variable React _ app _ pod name. And I have to use that React _ prefix because it is, that's the only thing that gets picked up by React for security purposes. You have to specifically tell it you have to use that format for your environment variable names, or they won't actually make it into your application. And then within that environment, I'll set it using the metadata of the pod itself. So that should get picked up. And then we got some, what does that mean? 10 minutes or something?
Yeah, sorry, I was already unmuted. Yep, that's 10 minutes left.
Cool. So I just added that to my pod configuration. Now I need to update my actual app configuration to use that. And so I'll just print it out. Process.env. Why does it keep doing that? So just using sort of the normal node syntax for grabbing an environment variable of process.env.environment variable name. Then I need to make build.
And is it possible to put this up on GitHub or something for when you're done?
Yeah, I can definitely bundle up everything and put it on GitHub. Yeah, so right now I'm rerunning my build command now that I updated my app to print out the environment variable name. What did I get? An error. Process is undivided. Oh, I spelled it process with 2 E's. I need the Colby debugger, but you can't see my screen, so.
Yeah.
All right, we built. Now I'm going to do make push. Pushing the image. Here we go. Now I need to essentially recreate all of my pods. So I'll do kubectl delete pods.
So all those pods that we saw running before, it's going to tear all those down and
Yeah,
basically
so
refresh them?
the nice thing about Kubernetes is because it has a closed loop system that's looking at the state of the world and trying to make sure all of your deployments match their config, I can just literally say, delete them all, and it will do that. And then it will immediately detect, oh, we have 0 and we want 5, and just spin up 5 new ones in its place. And
Yep.
that
and as
will...
we can see, I'm getting a 503 because they're all spun down. Yeah.
Yep. Try refreshing.
And we're back.
We're back, but we don't have the variable that I would have hoped we would have seen.
Are you able to see my screen?
I can see it, yeah.
Okay.
So that's what I was going off of. I'm going to jump into one of those pods and see if our environment variable got set like we wanted to get. So there's a kubectl exec command that you can use to actually run a shell inside of or run a command inside of a pod. So I'm going to do that.
So you're not necessarily like SSHing in, it's just running that one
It's kind of like doing that. Yeah, I run that one command and it essentially sets up a tunnel for me to have a shell running
cool.
live.
Okay.
So my React app pod name did make it into the pod like I wanted it to. But I wonder at build time, right? Because, okay, this makes sense, right? Because I built my static site and I'm running it as that nginx container. So whether that would have gotten converted, I think it would have built it and made that environment variable static when, like, at build time versus at runtime. So it's not picking it up in the pod.
I was wondering that, or if maybe the React hydration was overriding it or something. Like if it wasn't available in the client.
Yeah.
What would the variable say?
It would say something like Colbyashi Maru nginx and then a random string to show like the pod name. But it is not there. Oh, the variable name. There's no variable name. I was just printing it out. But yeah, it would show up as text there. React app pod name. App.js. React app pod name. I'm just going to put some hard-coded text there to see if the image change is indeed getting picked up. That'll give us a test. Make build image. Like now it should, once I push this and delete those pods, we should see pod name : and then probably blank because it seems like it's not working. But make push. Okay, I just deleted all the pods, so they should go down. And then when they come back up, hopefully we will see pod name : blank, and that will confirm that the change to the container did make it in, but how I'm reading in that environment variable is not working, which makes sense to me because I'm not actually running a node server, right? I'm running an nginx server. instead.
Right. I'm not sure if the lack of seeing the code is more tension or less tension. But looks like we have that text there.
Yeah, so that's proving to ourselves that we did indeed update the container, push that to the registry. That got pulled into the pod once I deleted all those other ones. But now that I think about it, it makes 100% sense that a node environment variable is not going to be available in this nginx container. What I could do as a hack, and I probably have like 1 minute left, instead of doing the
I wonder if doesn't React, when you use create React app, don't you have to use a prefixed environment name for when it builds?
I did use the prefix of React underscore app underscore env name, but right, like I'm not running this within a node. This is the actual web server is that nginx server. It's not a node web server, and so of course process.env doesn't exist in the same way that it does for node.
I was thinking of build time though, but maybe not.
But this variable that I'm trying to put there is specific to the pod that it's running in. It's the name of that pod, so it's dynamic and needs to be set later. I could run a node-based web server instead of nginx, and then it might work. But what I'm not sure about is, at whether that gets set at build time or at runtime. So
we have like 30 seconds left.
30 seconds left. I mean, we got it working. We deployed 5 copies of our site onto a Kubernetes cluster. We load balanced across it and provided ingress via the DigitalOcean load balancer. You just have to trust that it is actually load balancing across those, because
I believe you.
So that hopefully shows some of the viewers sort of the power of what Kubernetes provides. There's a lot of layers of abstraction there and complexity, and so trying to cram it into 1 hour is tough, but I think we made it pretty far, even with our screen share difficulties.
Yeah, no, absolutely. And we'll have the code later that we can that people can check out in the description of the video.
After this, I'm sure I'll figure out how to inject that dynamic variable so that we can have real proof that it's load balancing.
That sounds great. But it's awesome because, not only like the Kubernetes, but there's so much to unpack there, like the Docker stuff. There's a lot to learn, but that was awesome. So just a quick, I know you can't really show much, but do you want to kind of just walk through quick what we did today as a quick roundup?
Sure. I could even like push it to GitHub super fast, and then you could have it up on the screen if you wanted.
Yeah, sure.
Let me just make a repo. Okay. So it looks like because create React app did something, it like started from a repo. That code didn't get in there, but the Kubernetes code did. So that's what we want to look at anyways.
Yeah, that's fine.
And I'll fix that.
That's interesting though.
Yeah, it's like showing that it's already a repo. I'm not sure. Just go into Kubernetes, and the deployment is the application deployment config. Yeah, so we had 5 copies. It was based on this custom image that we pushed to the DigitalOcean registry there on line 19. We opened up port 80 for access. We tried to do that thing with the React app pod name. That environment variable did get set inside the pod, but it was not getting read in properly because we weren't running a node-based web server. And then the resource request tells Kubernetes how many resources are required for this application. Awesome. And then if you go to the load balancer, we didn't get to see on screen. It's pretty simple to set up. You basically just tell Kubernetes to set up this load balancer, and then the specific stuff to DigitalOcean is in the annotations there, telling it use load balance over HTTP requests and use the small type. I think there's a small, medium, and large. And so depending on your inbound traffic, you might want to use a different one of those. And then the bottom, just the rule from port 80 to port 80. So inbound requests over HTTP, when you just hit that IP address, get forwarded to my deployment on port 80 as well. And if we had time, we would have mapped that IP address to a domain with an A record, a DNS A record. And then we could go to like Colbyashi maru.devopsdirective.com, and it would map to this IP address and take that request all the way to the to the container, one of our many
Nice.
containers.
Yeah. And I know the whole like idea of here was like over engineering it, but this is definitely helpful for especially when you have situations where you're actually serving server code, right? Because if you have like one server serving millions of people, that really doesn't scale. But if you're having this
Yep.
load balance, it can automatically take care of trying to make sure the traffic is shared, right?
Yeah, exactly. So load balancing out of the box is a really nice feature of Kubernetes. You can do this in other ways. So like if we're thinking about AWS, you can have uh, an AMI, which is essentially the operating system and your app bundled into not a container, but more of a virtual machine image that it will spawn virtual machines with. And you can have that in an auto scaling group, and that will spawn new machines as there's more demand. And then you can put a application load balancer in front of it. Um, that is, you can only have like one app per machine in that case. In this case, you can have as many different types of services as you want running in one cluster. So
Awesome.
helps to simplify simplify your infrastructure in the end once you reach the threshold where this stuff becomes useful.
Yeah, for sure. Awesome. Well, thank you so much. Thank you for everybody who joined into us today. Sid, I'd like to thank you again for facing off on Colbyashi Maru. Please, everybody, make sure you go check out all of Sid's work on Twitter and his YouTube, where you can find all the links at devopsdirective.com, like I'm showing you here. I'll also post them in the chat. Next week, we're going to have Kurt Kempel, who's going to face off against building a federated GraphQL API with Apollo Server, Gateway, and Studio. Sid, do you have
Cool.
any last words?
No, thanks for having me on. It was fun. Even though we had some issues with screen share, we certainly over engineered static site deployment. So
We certainly did. Cool. Well, again, thanks everybody. And this is Colby signing off.